All right, we're back. We're still on page 6 of notes 20. We were talking about areas of regions bounded by curves, and now we're doing these kind of like weird problems where it's not enough to just have the area bounded by the region. Nope, the region bounded by the curves. Now we want to split that region somehow. So in the last problem, we split it so that it was even, which is probably the most common thing that you want to do. We looked at two approaches though. We did, one option was to just cut it in half and go from 0 to our vertical line, and then go from our vertical line to the other endpoint. That's one option. I thought that gave us an equation that was like a little bit harder to solve. But the other option is to just find the total area, cut it in half, and then say from 0 to k gives us that. So both of those are valid. And then I tried to illustrate that there are some extraneous solutions, but that did not go well. So let's take a look at this. So vertical. Oh, I just realized the reason that it didn't go well is that the Inspire is just programmed to always do top takeaway bottom, regardless of whether or not mathematically it should be doing it. So didn't work for us. Let's see if we can do this. So we want to find a vertical line between 0 and pi, okay, that divides the region bounded by the x-axis and y equals 3 sine of x into 2 regions. So I'm just going to graph that first. So 0 to pi, and then goes up to 3. I don't think that 3 is really relevant here. So this is pi. How do we want to divide this? The area of the region to the left of k exceeds the area of the region to the right by exactly 1 unit. So the area to the left exceeds the area to the right. So the area to the left is bigger, right? So if the area to the left, so we have the left and the right, R-I-G-H-T. Okay, with the left and the right. So the left exceeds the right by 1. So if this is 6, then the right would be 5. If this was 10, then the right would be 9, because the area on the left exceeds the area on the right by 1. So what I'm going to do is I'm going to try to draw that. It's not going to go well. I'm going to say this is k, right? And so what we have here is this line, and the area to the left, this area, whoa, God, what? Okay, this area is going to exceed this area by 1, which means that if I write two integrals, so I'm going to write one integral that goes 0 to k of, it's actually just 3 sine of x. And then I'm going to write another integral. That's the area to the left. The area to the right is going to be from k to pi of 3 sine of x dx. I would need to, if you look at all of these, right, I need to subtract 1 from the left to make it equal the right, or I need to add 1 to the right to make it equal the left. So what I'm going to choose, I'm going to add 1. So I'm going to say this is equal to this plus 1. If I add 1 to the area on the right, it's definitely going to equal the area on the left. So that's what we want to do. So now let's see, is there a way we can work this out? I guess we just integrate. So this will be -3 cosine of x from, I don't want to put an equal sign there, from 0 to k. So that's -3 cosine of k minus -3 cosine of 0, so plus 3. And then -3 cosine of x from k to pi, and then we'll add 1 at the end. Okay, so the cosine of pi is -1, so -3 times -1 is 3, and then minus -3, so plus 3 cosine of k plus 1. So I end up here with -6 cosine of k equals, so I'm going to bring everything constant to the right-hand side, so subtract 3, so equals just 1. Which means that the cosine of k is -1/6. So the question is, can k equal the inverse cosine of -1/6? Is that an answer that makes sense? I think it is, because here's pi over 2. So it makes sense to me that this is quadrant 2 of the unit circle. And inverse cosine of a negative puts you in quadrant 2. So I think this is the answer. I think the answer is K is cosine inverse of -1/6. So you got to think about that for a little bit. Let it sink in, right? So we're doing the inverse cosine of a negative, which is going to put you in quadrant 2. So the question is, did you want a quadrant 2 angle, or did you want a quadrant 3 angle where cosine is also negative? But I think in this case, we definitely wanted quadrant 2 because we're somewhere between pi over 2 and pi. I think that's good. An alternative answer, I guess, we could have just gotten the reference angle. So we could do like, or K equals, if we'd just gotten the reference, I don't know what happens when that happens. If we'd gotten the reference angle, we could say it's pi minus the cosine inverse of +1/6, right? Where the reference angle is the inverse cosine of 1/6. Also, I think that this would be a calculator problem. So I'm gonna do it on the calculator. Well, I'm gonna try to do it on the calculator. Let's see. Sometimes, so we're starting to run into that, like where we can set up problems that maybe the calculator can solve, maybe it can't solve. So I'm on problem 8. Wow, getting up there. So I want to try to solve the integral of 3 sine of x, comma x from 0 to k is equal to the integral of 3 sine of x, comma x from k to pi, and then I need to add 1, and then I want to solve for k, and I think that's all I need to do. Whew. Okay, then I want to put in such that 0 is less than k. That's not a 0. 0 is less than k is less than pi. So I get this. Arc cosine of -1/6. Same value, nice. Pi minus the arc cosine of +1/6. Same value. So we did it. Definitely, there's a lot to think about in this problem. So the first thing is you want to like set it up correctly so that, and if you have to play around with numbers to set it up correctly, play around with numbers, right? Like I wrote left and right, and then I picked some values and I just like made them make sense. So the area on the left is bigger by exactly 1. So I would need to add 1 to the area on the right to make it equal that. So that's how I like work those out. I actually think I'm gonna stop the video here because this one requires like a lot of thought. And I want you to like take a second and think about it. I'll be back in the next video. I will do the next one. So I will see you there. All right.